The next section we're going to cover is Chapter 3. Section 3.1 we previously covered, and here's a list of topics that we're going to cover. Looking at radicals, simplifying them, adding and subtracting them, multiplying, dividing them, rationalizing denominators, and solving radical equations. Next page. So the first thing we're going to talk about is a little bit of vocabulary. The number under a radical is called the radicand, and the root that you're taking is called the index. So remember that the symbol is called a radical. This tells us what type of root we're taking, the fourth root. The radicand is the number we're taking the root of. So in this example, the fourth root of 16. In your calculator, you would put in 16 caret, and 4 is the 1/4 power. If you put that in your calculator, you're going to see that you get 2. But we can also do this without a calculator. Remember that square roots mean groups of 2. So a cube root would be a group of 3, and a fourth root would be a group of 4. So if we take 16 and we break it down into prime numbers, 16 is 2 times 2 times 2 times 2. So the fourth root of 16 is really the fourth root of 2 times 2 times 2 times 2. And again, fourth root means you're grouping it in groups of 4. There's one group of 4, so your answer is 2. So this tells us how many we need to come out of the radical, and obviously the number that we're taking the root of. Next page. So simplifying radicals. You can break it down to a square root, a perfect square, and then whatever it's being multiplied by. But if you don't know what is the biggest perfect square that goes into the number, you can simply just break it down to factors. So 450 is 45 times 10. Keep breaking it down. 45 is 9 times 5. 10 is 5 times 2. So this is the same as the square root of 9 times the square root of 5 times the square root of 5 times the square root of 2. Each of these numbers is either prime or a perfect square. The square root of 9 is 3. Square root of 5 can't be simplified, but square root of 5 times the square root of 5 is just 5. And square root of 2 can't be simplified. 3 times 5, 15, square roots of 2. So you don't need to find, again, you don't need to find the biggest perfect square that goes into this number. Just keep breaking it down till you get either perfect squares or prime numbers. When we're doing it with variables, again, think about what square root means, that we're grouping them in groups of 2. So x to the 5th power is x times x times x times x times x, 5 x's. Grouping them in groups of 2. There's one group, there's another group, this guy, no group. One group comes out as x, the second group comes out as x, the one left over stays in. Simplifying, we have x squared square root x. Try the next two, pause the video, try the next two on your own, and then come back and see if you got them correct. So 12y to the 7th power. 12 breaks down to 4 and 3 and 7 y's. We have one group of y's, two group of y's, three group of y's, one left over. So one group, two group, three groups, one left over. Square root of 4 is 2. Square root of 3 can't be simplified. Combining your y's, 2y cubed, square root 3y. And the last one, 50 is 25 and 2. Square root of 25 is 5. 2 stays under the radical. 3 a's, one group comes out, one left over. 2 groups of b's come out, one left over. Next page. Okay, so when dividing radicals, remember the rule is that you can, if you have it under one square root, we can separate it, or vice versa. If we have it separated, we can go back. And we'll talk about that again in a minute. So, square root of 8 over square root of 9. So we can write that as, or the square root of 8 ninths as the square root of 8 over the square root of 9. Square root of 9 is 3. Square root of 8, 4 and 2. So 2 square roots of 2 over 3. 4 and 5. Square root of 4 over the square root of 5. Square root of 4 is 2. Square root of 5 can't be simplified. We are going to rationalize the denominator. If you recall, you can't leave radicals in denominators. And we'll talk about that in a minute. So we eventually will simplify this. Next one. Square root of 64. Square root of a cubed. Square root of 6. Square root of b to the 4th. Square root of 64, 8. A cubed, one group, one left over. In the bottom, 6 stays in, b to the 4th, 2 groups. And the last one, 4th root, sorry. So it's the 4th root, so think we have to have groups of 4. So 32 breaks down to 16 and 2. I'm ignoring the variables for a moment. And 16 breaks down to 8 and 2, and 8 breaks down to 4 and 2, and 4 breaks down to 2 and 2. So what we can do is list 32 as 2 times 2 times 2 times 2 times 2. 4, 8, 16, 32. So 32 is 5 2's. 5 x's, 4 y's. Now remember, we're taking the 4th root, so we want groups of 4. So, one group of 2 comes out. 1 x comes out. 1 y comes out. What do we have left over? And I'm going to change that a little bit. Make sure your 4 or your root is near your radical. Make sure it doesn't look like it was y to the 4th power, not the 4th root. So be very careful, leave spacing in there. So what do we have left over? 2 and x. And again, the 4th root is critical there. And the next page. So to add or subtract radicals, they have to be like terms. So the first thing is we have to simplify each radical. You can't combine these the way that they are. You can't say this is square root 58. Think like variables, even though they're not variables. Think like variables. We have to combine like terms. So 50 is 25 and 2, and 8 is 4 and 2. So 50 equals 5 square roots of 2, and 8 equals 2 square roots of 2. Now they're like terms. We have something with a square root of 2, another thing with a square root of 2. Now we can combine them. 5 plus 2 is 7. So we have 7 square roots of 2. 75, 25, and 3. 48, 16 and 3. So we have 5 square roots of 3 minus 4 square roots of 3. 5 minus 4 is 1, So 1 square root of 3, or just square root 3. Number 3, 10ab squared minus 250ab squared. The only thing here that can be simplified is the b squared. So we have b square root of 10a. 250, 25, and 10. So minus 25 comes out as 5. Square root of b squared is b. I have the 10 left over and the a left over. Again, they're like terms, not only because the radicals match, but because the b's on the outside do. If this matched with this, but this, say, had an a in it instead of a b, then we still couldn't simplify it anymore. We could factor out the square root of 10a, but we couldn't completely combine them. So now we have 1b minus 5b's, so we have negative 4b square root 10a. Last one, square root of 9x, 3 square root x. Square root of 16x, 4 square root x. 3 plus 4, 7. That ends the video for today. See you in class.